All right. Hello, everyone. I just wanted to make a quick video for you to solve these last couple of problems in section 3.7. So I didn't get to do these in class. My guess is that most of you can fight through these, but I just wanted to have you, just to give you some guidance in case it's helpful. All right, so let's do number 3 here. If f of x is equal to 21 times e to the 0.47x, calculate the value of x such that f prime of x equals 2. Okay, so this is our function, and we are asked to figure out what values of x make f prime of x, my derivative, equal to 2. Well, in order to figure that out, we need to know what the derivative looks like and set it equal to 2. So let's start with that. So if I want to find f prime of x, I'm going to have to take the derivative of f of x here. So I've got 21 times e to the 0.47x. So this is a number times e to some stuff. That I know how to take the derivative of e to the x, but this isn't just e to the x. This is e to some stuff. So this is 21 times e to some stuff. How do you take the derivative of 21 times e to some stuff? Well, the derivative of e to the x is e to the x, and if you multiply by a number out front, it comes along for the ride. So the derivative of 21 times e to the stuff is 21 times e to the stuff times the derivative of my stuff. And my stuff here is just 0.47x. So this is going to be 21 times e to the 0.47x. Oops, that's an x. Sorry. Let me try that again. There we go. Okay. 0.47. Whoa. X. That's better. And then we're going to multiply by the derivative of 0.47x, which is just 0.47. So at this point, that is my f prime of x. We can just see if we can simplify this at all. We can multiply our numbers here. 21 times 0.47. Let me put that into my handy dandy TI-30X2S. And we get 9.87 times e to the 0.47x power. That is my derivative. But that's not all I need for this problem. I need to set it equal to 2 and solve for x. So I'm going to set my derivative equal to 2. And then we have to solve this thing for x. So now it's trying to remember how to solve an exponential equation. To solve an exponential equation, you need to get your exponential expression, which is your base to a power, right? That's this part, base to a power, completely on its own. It is not currently on its own in this problem, so we need to divide both sides by 9.87. So 2 divided by 9.87 is e to my 0.47x. From here, in order to get to x stuck up here in the exponent, we need to apply a logarithm. So you're going to take the log of both sides. You get to pick the base. Generally, we want to pick either base e or base 10. Because the base of my exponential here is e, I'm going to pick log base e, which is the natural log. So I'm going to take the natural log of both sides. And when we do that, the base of my natural log is e, so these guys cancel out and we just get 0.47x. That's what we have left here. Just wanted to write that a little bit better. Okay. So now I have that the ln of 2 over 9.87 is equal to 0.47x. From here, you're just going to divide both sides by that 0.47. And that means x is going to be equal to whatever you get when you put this into your calculator. And when I do that, let's see, we'll do the ln of 2 divided by 9.87. 0.87, and we're going to divide by 0.47. And we get negative 3.396. That is the x value that gives me a derivative value of 2. Okay. Again, I just kind of wanted to go through that with you. It's been a while since we've solved an exponential function, so I wanted to go through that and make sure you had some help there. And then this last one, the power P in a circuit is given by P equals R times I squared. R is the resistance and I is the current. I want to find dP dt. That's the derivative of P, which is my power. And my variable should be T. I don't have any T's in there. We'll figure that out in a second. I want the derivative of P. My variable is T. At T equals 1/3. If my resistance R is 3,000 ohms, this little omega symbol is just the symbol for ohms. That's the units here. And I varies according to the equation I equals 4 the sine of 4 pi t. Here's my t value. So this is what's going to help us get to a variable of t. That makes sense to me. Okay, so what I'm asked to find here is dP dt, the derivative of power, that's this guy, with respect to little t. So my variable should be little t. So I have to figure out how to go from this equation to something with t's in it so that I can take the derivative. And then I'm going to plug 1/3 in for t at the end. Okay, so my resistance is 3,000 ohms. So I can put that into my function here, right? So we're given that R is 3,000 ohms. And we're also given that I is the sine of 4 pi t. So I'm going to plug both of these into my function. So my power function is going to be 3,000 times the sine of 4 pi t squared, right? I plugged R in here. I plugged I in here. And now I have P, that's my function. I have T as my variable. Now I just have to find the derivative, dP dt. Okay, so how do I find the derivative with respect to t of this function? Well, the 3,000 is a number being multiplied out front. It's going to come along for the ride. And I have stuff squared. So this is going to look like 3,000 times 2 times my stuff, which is the sine of 4 pi t to the first power, right? That's the derivative of my outside. And I have to multiply that by the derivative of my stuff, which is the sine of 4 pi t. I'm going to hit the pause button here for a minute. And there's my first chain rule. Okay, so now I have to fight through the derivative of the sine of 4 pi t. And I'll go ahead and simplify this a little bit as we're going. So 3,000 times 2, that's 6,000 times the sine of 4 pi t. And then I'm going to multiply that by the derivative of the sine of 4 pi t. That's the sine of some stuff. This is stuff inside a sine function. So the derivative of sine x is cosine x. So the derivative of sine of some stuff is cosine of my stuff times the derivative. I said the derivative with respect to x. It's the derivative with respect to t of my stuff, which is 4 pi t now. And again, I'm hitting the pause button here. If you don't need to hit the pause button, then you don't have to show all of this. But if you need the pause button, go ahead and pause. And then from here, we're going to have 6,000 times the sine of 4 pi t times the cosine of 4 pi t times the derivative of 4 pi t. The derivative of 4 pi t is, yep, just 4 pi. So overall, I can combine my numbers here. 6,000 times 4 pi is 24,000 pi times the sine of 4 pi t times the cosine of 4 pi t, and we are done with our derivative. So the derivative of power with respect to time looks like this. And we are asked to find the derivative at t equals 1/3. So I'm going to take my derivative and plug in t equals 1/3. I'm going to get 24,000 pi times the sine of 4 pi times 1/3 times the cosine of 4 pi times 1/3. And so this is going to be 24,000 pi times the sine of 4 pi over 3 times the cosine of 4 pi over 3. And now we just have to do some trig. Okay, 4 pi over 3. That lives down here. This is a pi over 3. So I'm going to have the ordered pair. My brain doesn't want to do this right now. So it's -1/2 negative root 3 over 2. There we go, trig. That is the ordered pair on my unit circle. And so then I'm going to plug those in here, and I'm going to get 24,000 times pi times the sine value at 4 pi over 3, which is our y coordinate, negative root 3 over 2, times the cosine of 4 pi over 3, that's our x coordinate on the unit circle there, which is -1/2. And so when I multiply those, this becomes positive, and this is all over 1. So I'm going to get 24,000 pi times the square root of 3 all over 4, which when I simplify that, I get 6,000 pi times the square root of 3. And what are the units on this? It's a rate of change. So it's going to be the units of y over the units of x. And again, this is why I think that Leibniz notation, this is where it shines, is it's going to be the units of the thing on top per units of the thing on bottom. So it's going to be the units of power. In our case, the power in a circuit, it doesn't even tell us, does it? Yeah, I'm not sure what the units of power would be. I am not a physicist. So it's going to be whatever the units of power are per unit of time, which is in seconds. So it's going to be units of power per second. So I'm not really sure what the units of power are, to be honest with you, because that is outside of my wheelhouse. So those are going to be the units, but we are not told power units here. So that's kind of where we're at there. Okay, so hopefully that helps you with your homework here. With this one, just fight through it. It's a chain rule inside a chain rule. So be real careful with that. You got this. Fight through section 3.7. The chain rule is a confusing one, but it's a really important one. And especially start wrestling with chain rules inside other rules inside chain rules. We have to start figuring out how and when to apply those rules. So have a lovely calculus full weekend, and I will see you next time.